Welcome back to part 3 of our regression lessons. Alright, so for this one I would like for you to write down your shoe size and height in inches as we had done on the Starn survey previously. And we're going to need some volunteers for just to share their shoe size. Alright, so my height is about, I'm going to put down 65 inches. I'm between 65 and 66 inches. And my shoe size I kind of vary between a 7 and an 8, but I'd say more like a 7.5 these days. All right, so now you guys have my height and shoe size. All right, now we'll come back to the height and shoe size for a lab tomorrow. All right, so look for the Excel spreadsheet where you fill this stuff in for those of you who are actually in my class. All right, now for our first example, we are going to take a look at the asking prices of some used Toyota Corollas advertised in the newspaper classifieds on October 1st, 2006. All right, so we have one that was a model year 2004. Since this is now 2006, that is 2 years old. And the asking price is $10,950. We'll get to the concept of residuals here in a minute. The 2003 Corolla is 3 years old. 2001 Corolla is 5 years old. The 1998 Corolla is 8 years old. The 94 Corolla is 12 years old. And finally, the 1989 Corolla is 17 years old. All right, so this basically just helped us to create a list of points that we can plot on a graph. All right, we're going to look at asking price versus age in years. All right, so our first goal is to create a scatter plot of the data, and we need to be careful to scale and label accurately. All right, so along the x-axis, I'm going to put the age in years. And the important part of putting the age in years along the x-axis is that we have to consider what's going to be our explanatory variable versus our response variable. Nothing's really going to change the age of an item, and we don't have a time machine, so we can't exactly go backwards and make something younger, and we can't really fast forward time to make it older, so age happens independently, which is why the years or the time that it takes for something to happen is typically on your x-axis. Now, what happens over time is that the price has a tendency to decrease. Now, sometimes it'll increase depending on the vehicle. All right, if you have a classic car, then you could end up with an increase in price. But most vehicles will actually decrease over time, which is what we see happening here. All right, but those are the reasons I'm putting age in years at the bottom, and I'm going to put the asking price along the side here in dollars. All right, now I am going to start at 0 for my x-axis. I'm just going to kind of extend this a little bit and put an arrow. And I'm just going to go by ones here. I think I have enough lines to be able to fit all of these numbers here. So 1, 2, 3, 4. And I did have enough space. Excellent. Now likewise, I'm going to go up my y-axis, and my lowest price is $1,500. My highest price is just over $10,000. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I go up by thousands, I'm going to be close to the top by the time I get to 10,000. So I'm actually just going to go by thousands. I'm not going to try to go by 500s or anything. I would have to extend this graph if I were to go by 500s. I don't have enough space. So I think thousands is my best bet. And I'm actually going to start at 0 this time. You don't always have to, but I'm going to start at 0 this time because I have such a wide range of values, and I have a number that, if I'm going by thousands, is close enough to 0 that I might as well just start there. So I have 0 here, I have 1,000 on my first line, and I'm just going to count this up. So this is 1,000, 2, 3, 4, 5, So I have 5,000, this was 1, 2, 3, 4, 5 right here. And then 6, 7, 8, 9, 10. All right, so my 10,000 mark is right there. So I'm showing what I'm going by at the very beginning, and then I'm just going by convenient intervals here just to make sure that I'm, giving myself general markers to make it easier for me to count. So I am still going up by 1,000. So this is still 1,000, 2,000, 3,000, 4,000, then I hit 5,000. You just don't have to write down every number, but you do have to account for every number. So do be careful that you are not making uneven gaps between the numbers. If one box's height counts for $1,000, then one box's height up towards the top of my graph has to count for $1,000 also. You have to be really careful with this. Don't just try to list all of these numbers. That will never be a valid graph. It would be very inconsistent. All right, so now I'm going to go ahead and plot those points to get my scatter plot. And let's see. So 2 years means I need to be on this line, and 10,950 is going to be really close to 11,000, so I'm going to, oops, that was on the 3-year mark. Don't be afraid of making mistakes. It happens. As you just saw it happen to your teacher also. All right, so in the 2-year mark, we're going to be just below $11,000 because we're just about $50 shy of it. Now on the 3-year mark, we are at 9,400. So I'm going to be a little bit less than halfway between the 9,000 and the 10,000. At 5 years, I'm going to be at 8,990. So 9,000 was right here and 8,000's here. I'm just $10 shy of it, so I'm going to be almost right on that 9,000. And then I need to go over to 8 years. Be very careful to make sure that you're leaving the appropriate gaps in the x direction. All right, so I need to go to 8 years, 5,800. So I go to my 5,000. I'm not quite going to get to 6,000, but I'm also going to be well more than halfway up there. So I'm going to mark it about there. And then in 1994, that was 12 years and just shy of the 4,000 mark by about $200 also. So I'm going to space that about like I did this one. And then 17 years, that's 1,500, which makes it exactly halfway between the 1,000 and the 2,000. All right, so now I have my scatter plot. And, it looks like it could be linear, but it also looks kind of like these points might be dipping down a bit. So I'm not quite sure if it's linear or curved. Now that's actually the danger of having too few data points. When you only have, let's see, how many data points do we have here? 1, 2, 3, 4, 5, 6 points. When we only have 6 points, it's really hard to see what shape the data is truly taking. The more data you have, the easier it is to see if your scatter plot should be considered linear or nonlinear. So just kind of keep that in mind as we go through. It's rather difficult to figure out whether or not your data is truly linear based on just 6 points. All right, now we're going to go through and actually calculate the regression equation. And the line of best fit is something that we teach you in middle school and early high school that you can kind of eyeball, but the true best version of the line of best fit, so the best version of the best fit line, the best fit trend line, is always going to be done with the calculator. The calculator can get far more exact in calculating, actually minimizing the sum of the squared residuals, which is something that we calculate down here. Basically, it looks at the distance between the line and the points themselves in the y direction, which is how we calculate residuals. And we try to minimize that as much as possible so we can get our line as close as possible to each of the points without maximizing the direction of the line from any of the others. So best done with a calculator. So in order to do this, I am going to go to first I turned it on, I'm going to go to mode first, and I'm going to look down this, and I need to look for stat diagnostics. In order to get all the information I need, because in question 4 it asks for the correlation coefficient, I have to turn on the stat diagnostics. All right, so mode is where you find this. Look for stat diagnostics, go over to on, hit enter. So what I did is I hit this enter button down here, and that's what allowed that black box to move from the off to the on. All right, so now I'm going to go through and hit second mode to quit out of the screen. So kind of like with a computer program, you want to quit out of it. And then I'm going to go to stat. All right, we are going to be using statistical calculations to be able to come up with our regression equation, which is why we're using the stat button. All right, anytime you want to actually enter raw data, you need to go to stat. All right, so I'm going to hit enter on edit. And I have some previous data here. Anytime you have data left over in one of these lists, what you want to do is arrow to the very top of it and make sure you hit clear. If you hit delete, you're going to delete the entire list, have to delete all of them, reinsert all of them, and that can be a real pain. So only hit clear and watch what happens down here at the bottom. All right, you see all those numbers there? Hit clear. And now all those numbers disappeared. Now they still appear in the list because I haven't completed that clearing operation yet. I've just cleared them out from what's supposed to be in list 1. To complete this, I'm going to hit the down arrow and go back into the list, and now it applied that clear to that entire list. All right. Now I can go ahead and type in my years old into list 1 for my X's and my asking price into list 2 for my Y's. I typically use my list 1 for X's, list 2 for Y's, because usually when we write a table of values, we put our independent variable first, our dependent variable second, because the independent is generally used to make predictions about the dependent. All right, so I'm going to type in 2, hit enter. All right, so between each of these numbers, you want to hit this enter button. And as I hit enter, it advances to the next line. All right, 3, enter, 5, enter, 8, hit enter, 12, 17. And once you reach the bottom of this, now I'm going to hit the right arrow in order to go to the side to enter into list 2. All right, see how that just transferred over to that side? And now I'm going to type in the asking price. So 10,950, enter. 9400, 900. Whoop. Always double check your numbers as you're going through. I usually check my numbers before I hit enter so I can fix anything that's going wrong with them early. All right, so I just caught that I had originally typed in 2 zeros instead of a 90 at the end. Be very careful with that. Always double check what you've entered in, because the calculator is only as good as what you enter into it. If you don't enter the correct data into it, then it can't very well give you the right answers. All right, now double check to make sure that you have a Y value with each of your X values, because since this is a table, it's going to use the two numbers together, and if you don't have all of your numbers typed in, if you accidentally skipped one for one of those lists, then you would have an uneven data set and it would give you an error message. So always make sure that you have the same amount of numbers in both list 1 and list 2 when you are using this for regression. Now once we have all of that done, I'm going to hit second mode to quit out of this and go back to the stat button. All right, once in there, I'm going to do calculations with the numbers I just entered. So I need to hit the right arrow to go to calculate. Now, what I want to do is a linear regression. There are a whole bunch of different things in here that you can calculate. There's single variable statistics, there's 2 variable statistics, there's this median thing, there's 2 types of linear regression. Now, in your algebra classes, you're used to seeing slope times x plus y-intercept. However, in statistics classes, we typically use the y-intercept plus slope times x. So in statistics classes, we start with the initial value, then we add on the change times the number of times it's happening. So it's kind of up to you which one you want to use. I think I'm going to go with number 4 because this class is based more on like the algebraic applications of data analysis. And so I'm going to go ahead and stick with number 4, the version that you're likely more familiar with. If you want to go with number 8, please feel free to do so. Number 8 is what I would typically use for one of my AP statistics classes. All right, now once in here, look at what we have. We have our X list, which is list 1, our Y list, which is list 2. We don't need a frequency list. A frequency list would be if we didn't list out every single point, the exact number of times that it appeared, and we did, so we don't need a frequency list. Everything appears as often as it should. we can store the regression equation if we want. So let's take a look at how to do that. In order to store a regression equation, you have to identify the variable that you want to store it under. And variables is what vars controls. So push the vars button, and then you can choose to go over to the y variables. We are currently doing regression for a function, and we would want to enter this into y1. All right, so now once it calculates this equation, it's going to actually store it for us in y1. And this will come into play here in a few. Definitely store your regression equation. It'll make your work a lot easier. All right, I'll show you the by hand method, then I'll show you the calculator method and show you how it's easier. All right, so calculating, and this gives us the a value is our slope, the b value is our y-intercept, and then we have these other two components. Now the bottommost one is the correlation coefficient that we were talking about previously. All right, in our previous couple of lessons, we talked about how to determine the direction and strength of the relationships that we're looking at. So by all appearances, this seems to be a very strong negative correlation based on this negative 0.098698 and so on number that we have here. Now the r squared and the r value would not have appeared if we hadn't turned on the stat diagnostics in the mode. That's what turning that on actually did for us. If we didn't turn it on, if it had remained off, all we would have had would have been A and B right here. All right, so always make sure you turn that on so you can actually see these two diagnostic values. And they're called stat diagnostics because they're some of the things that we use to actually determine how good this relationship is, how much of the variation is actually explained in the y by the change in x, and also how strong and what direction the relationship's actually going in. I think it's pretty obvious that this is actually a negative relationship, as that negative sign actually shows. So we'll get back to these here in just a moment. Let's go ahead and write down our equation here. So when we're talking about the regression equation, we always put a hat on the y. It's this little upside down V, and that hat represents our predictions for our y value. So the predicted y value. All of these numbers were numbers actually found in the newspaper. Numbers that we get out of our equation are numbers that we're calculating as an estimate of what would happen, as opposed to a real life value that we actually pulled from some source. There's a big difference between both of those types of numbers, between the actual y value and the predictions that we get for y values. So we have to identify which one is which so that we don't start fabricating the details of the situation. We always have to separate fact from fiction that we think could become fact. And notice that I'm rounding up. Typically, whenever you're dealing with things that are financial, the third decimal place within dollars and cents will typically get rounded up. So the 5.5 became a 6. The 1.6 here rounded up to a 2, which is why I have 0.92 right there. So what this is saying is that our initial value for a brand new Toyota Corolla was estimated to be at about $11,633.92, and that for every year that the Toyota Corolla ages, its predicted asking price would decrease by about $624.76. And that's actually the interpretation of our slope in words. So when you're interpreting, you're actually explaining the real life meaning of a number. One of the whole things about doing statistics is to figure out what your calculations tell you about real life. And what this equation specifically is telling me about the real life situation is that the predicted asking price of a Toyota Corolla decreases $624.76 for every year it ages. Now, aging implies that the years are increasing, which is why I'm able to write it that way. You could say for every 1 year increase in its age, that would also be acceptable. Notice that when I said decreases, I didn't include the negative sign. The negative sign became the word decreases. So the sign on the slope, whether it's positive or negative, turns into the word increasing or decreasing when you're talking about the general trend of those values. So for every single year that this thing is aging, so as the x is increasing, I'm expecting a decrease specifically of about $624.76 for every single one of those years that it ages in my predictions. And it's important to emphasize that's the predicted asking price, not the actual asking price. All right. Asking price depends on many different factors. It depends on the condition of the vehicle. It depends on the market that that vehicle is actually entering into, if there's a shortage in used vehicles, things like that. So you have to take into account many different issues like the mileage on the car as well. So it's not always just age, but age does have something to do with it. It's a very strong indicator. All right, so this would be our interpretation of slope. And now we need to write down our correlation coefficient. The correlation coefficient is the R value, so I'm going to go ahead and write down this R value. So R is equal to negative 0.986984. I'm just going to put 3 dots after that so I don't have to keep writing out that number. You could round it and make it like negative 0.987 approximately. I wouldn't round to 2 decimal places. I'd probably at least take it out to 3 just so that you know it's a 0.98 something instead of a 0.99. That actually makes a little bit of difference in terms of the strength. Now, both are very strong, but if you're trying to compare 2 different models, you would want to actually pay attention to that. Now, interpreting R in words. So the interpretation of this is that the relationship between age and asking price is very strong and negative. All right, so the relationship between age and asking price is very strong and negative. That's the interpretation of this R value. Now, notice I didn't actually include the number in this. The very strong part of this is where the number comes in. The sign of the number is the fact that this relationship is negative, that as our age is increasing, our asking price is decreasing. That's the negative portion. So all this number really indicates is how strong the relationship is and what direction it's going in. And that's what you state here. Now, determining the residuals. All right, so determine the residuals in the column above, so up here. And the residuals are specifically the calculation of the actual minus the predicted y values. So the actual y values minus the y hat values meaning the y values that you would actually get from putting these x values into this equation and finding the predictions for the y values that we were already dealing with. Now what this does is it actually calculates for us basically the distance between our line and our points vertically. Now, let me show you what this really means. So I'm going to go in and actually plot this. So I'm going to hit second y equals to deal with my plot. I'm going to hit enter on so that I can adjust the type of graph. And I want to scatter plot, so that very first type. And I want to have my x list be my list 1. I'm going to make my y list be list 2. So second and then 2. You see all these numbers here where you basically have list 1, list 2, list 3, and so on listed out in blue. Well, the blue button is the second button, so that's why I'm hitting second, and then I'm going to hit the number 2. And then list 2 actually appeared here. It's very important that you choose the list name that's above the 1 through 6 buttons. If you try to type it in with the alpha key and a number, it's not going to mean the same thing. And it actually shows up differently. Notice that the 2 and the 1 are actually in a subscript format. That differentiates it from just typing in a letter and a number. All right, now once I've done this, I'm going to hit enter. And then I'm going to go to, let's see, I'm going to go to my y equals screen. Now, do you see how my equation that I had, that the calculator had calculated for me, it stored it into the y1 equation spot? That's a good sign. And I'm going to go to zoom, and I'm going to go to zoom stat specifically. So hit the 9 button to go to zoom stat, or you could arrow down and hit enter on zoom stat, either way, but I'm just going to push this 9 button. And what this does is it actually goes through and it creates the graph that I have here. So you can see the points, and then you can see generally about where this is. And I'm going to use that, and I'm going to, give me 1 second here. I need to find where my ruler went. And it appears to have vanished. So instead, I'm going to kind of old school this and use a couple of sheets of paper to kind of mimic this. Now, I know that my y-intercept is 11,633, so a little bit above 11,500. So I want to be just a little bit above here. I need to sort of hug these. That looks about right. So I'm going to very carefully to not move my papers. This is what you do when you just don't have a ruler that you can find. And voila. We have something that looks very similar to this. All right, so I have an approximation of my regression line on here. And the vertical distance between each of these points in this line is going to be the residual. It's the leftover between the actual y value and the predictions that we just made, because we generally just make predictions on the y values. So like this distance right here and this distance here, this distance, notice that this one's kind of bigger than the rest. All right, this distance, that actual difference between the real y value and the prediction that we get from our equation, that's what the residual is. That's why you're doing a subtraction problem down here. Now, if you want to do this by hand, you can. You can type this in, so -6. Notice I'm using the negative sign down next to the decimal point for my negatives. Be very careful to make sure that you use a negative sign, not a minus sign. Use negatives for negatives, minus for minus. The calculator won't know the difference unless you actually tell it that it should use the other thing. All right, so -624.76 times 2, because it's 2 years, plus 11,633.92, enter. This is my predicted value. This was my actual, so I need my actual minus my prediction. So I have minus 10,384.4. I'm going to go ahead and type in my 10,950 minus, and then I'm going to go up here and grab that number, hit enter, and that means that my residual is $565 and, approximately 60 cents. So what that tells us is that our actual asking price was $565.60 higher than the prediction that we had. Look at the actual and then the predicted. The predicted is actually smaller than this, and because you are subtracting from the actual, if you have some left over, that means that the actual y value was larger. So positive residuals means that the real value was larger than your prediction. Negative residuals means that the real value was less than your prediction. So down here, I'm actually expecting a negative residual. All right, so let's take a look at how to do that one more time. So we have, just going to go ahead and hit enter on that to re-enter that real quick. Replace the 2 with a 3. And this is my prediction for 3 years old. Now notice that this prediction is actually more than the actual list price. There are a variety of things that could cause that. Just general variation, but also the fact that there is some variability depending on the quality of the vehicle and its condition, its mileage, including, with that, its age. So because there are more factors than just age that go into it, that's why you would actually have quite a bit of variability in this. All right, so now we're again going to go through and I'm going to type in my actual value because you always start with your actual. And then I'm going to subtract the number that we just had. All right, so my actual asking price was less than the prediction by $359.64. All right, so my actual asking price was less than my prediction by $359.64. Now, if I don't want to go through and do these all by hand, because this video is already getting long enough, if I go back to the stat button and I go over to edit and I go up to list 3 here, I can actually assign it. I go to the vars, I can assign this, not the vars, my bad, list, that's what I wanted. I can assign it to basically come up with a list of all the residuals from the equation that I saved into Y1 that I had done my calculations with. So this is going to give me the list of all my residuals, hit enter, and now I am seeing basically what I had here. Now these are a little bit more exact because they're using the full equation, not my rounded areas here. So if you want to do this, you could always adjust these a little bit to match. I'm just going to go ahead and write the rest of these in. So I have 479.86. I have negative 835.9, negative 336.9, and 486.92. All right, so this is the quick way to be able to get all of your residuals, so you don't have to do all these by hand, but it's important to know how they're calculated so that you understand the meaning of them. All right, now the sum of the squared errors is basically the sum of all of these numbers when they've been squared. So you square them, then you add them together. So let's take a look at that. And this is what you're actually trying to minimize when you are figuring out your best version of your least fit or your least squares regression line. It's why it's called the LSRL, the least squares regression line. It's the regression line that basically gave us the least sum of the squared residuals. So least squares refers to minimizing what we're about to calculate and the fact that we squared the residuals. If you just add up all the residuals, you'll get 0. It'll happen every time. So what you have to do is you have to actually make sure that you square them first, then add them up. All right, so do be careful with that. So let's take that 565.6 squared plus negative 359.64 squared plus, and I'm just going to put ... here and write my last number, 6.92. So I showed the pattern of what I was doing and then said I was going to continue in that same manner until the end of this. And I'm going to get out of my list. So I hit second mode to quit out of it so I didn't accidentally clear anything. Hit second mode to quit. If you just try to hit clear every time to move from screens, then you're going to end up with accidentally eliminating half the stuff that you needed, and you don't want to have to re-enter all of that. All right, so I'm going to start typing these in just like I was down here. So I'm going to use these parentheses, 565.6 squared. Please don't forget your parentheses. When you have these negative numbers, if you don't put parentheses, you will get the wrong answer because putting parentheses around a negative number before you square it squares the negative as well. Leave off the parentheses, you're not squaring the negative. All right, it's basic order of operations. The exponent is only effective on what it's directly attached to. Right now it's attached to the parentheses, which means that everything in the parentheses is affected. When you don't include the parentheses, it's only attached to the number itself, not its sign. All right, so you have to be really careful with that. Make sure you include those parentheses. Don't get lazy and leave them off. You'll just end up having to redo the problem and waste even more time instead of just being done with it. So that's one of those moments where trying to take a shortcut really bites you in the tush. We have 336.9 squared plus 486.92. And notice that I just went ahead and put parentheses around all of the numbers before I squared them. If you get in the habit of putting the parentheses around all the numbers before you square them, then you don't forget to do it on the negatives because you're just doing it to all of them. It eliminates a very common mistake. All right, hit enter. And this is the sum of my squared residuals. All right, so I have, this is going to be approximately, let me just double check this real quick. All right, so that looks good. That one looks correct. Yes, those look good. So I'm going to go ahead and just clear that line. 1728831.416. Now, believe it or not, this is actually the least sum of the squared residuals that we could possibly have. It doesn't seem like it because it is a large number, but then again, we were dealing with large numbers, so that was kind of expected. I mean, you're dealing with car prices. You're not exactly going to get a small sum of the squared residuals. All right, so this is what we were actually trying to minimize as we were wiggling through this. Now, any other line you would try to create, I challenge you. If you think you can draw a better line than this, go ahead and try it. Recalculate your residuals, find the sum of the squared residuals, and see if you can beat that number. All right, if you can beat the number, then you'll have won the internet. And I'll want to know how the heck you did it. All right, now, which year-old Corolla provides for the largest residual? And why is this one so large? Well, as we look through this, a large residual is relative to what it's being compared to. So when you're looking at large residuals, you're looking at them devoid of their sign. So you're looking at the absolute value of the residual. So I don't want to look at just the positive numbers. I want to look at the negatives also. And this one has the greatest difference from the line because this point right here at 8 years is actually the furthest from the line. And the distance that point is from the line in the y direction is what generates the value of the residual. All right, so it would be the 1998 Corolla because its actual Y value, or its actual asking price, is farthest from our prediction. All right, let me fix that U because it looked really funky for a second. There we go. All right, so the 1998 Corolla, because its actual asking price is farthest from our prediction. All right, we're almost there. We're almost done. Hang in there. All right, now we need to predict the value of a 1996 Corolla. All right, we need to show our work. Now, when you're finding your predictions, make sure you put that hat on that Y, because we're going to be using our equation, and our equation had the hat on the Y. So we need to make sure that we actually put the hat on the Y over here. So 1996 would be a 10-year Corolla. So I'm going to take my equation. So negative 624.76 times 10 plus 11633.92. You can use your calculator for this. And you should end up getting about, don't forget to put your dollars on here, but you should get about 5,386, that doesn't look like an 8, and 86.32. So $5,386.32 would be our prediction for this. Now we're going to predict the value of a 1998 Corolla. So same type of work again, so negative 624.76 times, now 1986 all the way up to 2006, that would be 26 years. That's quite an old vehicle. 633.92. And this is going to be, ooh, okay, let me show you this one, because we get a really weird answer. Negative 624.76 times 26 plus 11,633.92. We actually get a negative number. Now, hopefully that negative number is sending warning bells through your head, because that would mean that someone's paying you to take the vehicle, and they're paying you just over $4,500. Now, that doesn't seem very realistic. So what's the difference between these? Why does this number seem reasonable and this number seem so far off? Well, in these two problems, we were making predictions using our regression equation, but one of them is invalid due to a statistical error we call extrapolation. Oop. Give me one sec, my pencil just decided to drop its lead. And I need to put some more in it. There we go. All right, so back to what we were doing. So extrapolation. You get the real unedited mathematical solving here. Now, extrapolation and interpolation are two ways of describing the predictions that we make. Interpolation is when you are basically making a prediction within the data you've already gathered. So like this 1996 prediction, it's right between the 1998 and 1994 predictions that were already included within this graph. Now, because both of those were kind of below our line, we might expect our prediction to be a little bit high, but it'll still be somewhere in the ballpark. Now, 1980, that's 9 years before our last actual value that we had to work with, which means it's way off the chart. It's way off the graph. And as you can see, based on our line, we're supposed to hit 0 pretty soon after this 1998 vehicle. But if you know things about cars, you know that typically once it reaches a certain age, it's sort of bottomed out as long as it's in decent condition. All right, so extrapolation think extra and then polation, because you're looking at the polarity of your predictions. So is it super far out or kind of close in? All right, this occurs when you take a value that is far outside of your data set's domain, and domain meaning far outside of the x values that we are actually working with. Remember, domain is x values. And the resulting prediction is invalid. And when we look at which car's prediction is not valid due to extrapolation, well, the 1980 vehicle was so far out there that we actually ended up getting a negative number, which makes no sense based on the type of problem we're working with, the asking price of a vehicle. From just experience, from life experience, we know that most people don't pay you to take away their car. Right, now, another thing that you want to kind of avoid, so this is a pitfall that we might run into. So you have to be careful to make sure that your predictions are reasonable based on the data, the amount of data that you gathered and the range of data that you gathered. You want to stay fairly close in. You can occasionally make an extrapolation that's like maybe a couple years out, it's like maybe 1987. 1986, but not all the way out to 1980. That's just not realistic. So another pitfall that you want to be careful of is the possibility that we might have nonlinear data. All right, so we used a linear regression, but in the beginning of the section, we had to determine if the scatter plot was linear or something else and potentially a curve as we're going through, because you always want to see what kind of regression equation should I use. Should I actually use a line? Should I use a curve? This looked like it could be fairly linear, but there's a slight little bit that might be curving. And there's a way that we put a graph under a microscope to kind of magnify those differences that we're seeing. So if you look at this, we have these points. I have one above, one below, then one above, and then I have two below and one above. Well, look at this. If this were to flatten out and kind of really augment those differences, I have one above, one below, one above, two below, and one above. But now, if we calculate the residual plot, so if we use the same x values, but now we plot our residuals instead, this is the graph that we get. And that residual plot really emphasizes the fact that this does seem to actually have a curve if we follow the central trend of the points. What you want is for it to be fairly evenly scattered above and below the residual equals 0 line, which is the x-axis in the center. You want it to be fairly scattered above and below. If there's no pattern within the data because it's fairly scattered, then the line that we had used previously was the right thing to use. If we have something like this where we have this curve, then we might want to reevaluate and take a look at the different types of curved graphs and see if we can eliminate the pattern within our residual plot. All right, so this is sort of a warning sign to us that we might want to go ahead and double check and see what could actually be happening with this. Is it really supposed to just go in a straight line, or is it supposed to be more of like a more gradual like curve where it sort of dips off? Possibly a mild exponential function where it just slowly decreases and then tapers off so that it doesn't ever actually zero out. That would kind of make sense for the asking price of a vehicle if these asking prices never actually zeroed out. A line would make them zero out, an exponential function wouldn't. All right, so something to think about. And on the next page, you're actually going to be practicing with this. So we're going to take a look at a whole bunch of residual plots, because residual plots are one of two important ways to see if our regression equation is truly the best fit. Right? No pattern or random residual plot is really good, but a pattern means that there's a better type of equation, and usually the pattern that you see is the type of equation you should try, which is interesting. It sort of magnifies the pattern that we should have gone with to begin with. So we have a whole bunch of residual plots, and I want us to identify any patterns in the following residual plots, basically determine if we should have used a linear model or not, based on whether or not there are any patterns. So in this one, do you see how the points are really evenly scattered above and below that residual equals 0 line? That means that the linear model was the best thing to use because there was no pattern in the residual plot. All right. And if you have a scatter plot like I was working with previously, let me show you how to get this on the calculator. I'm going to go to my y equals and turn off my enter. Okay, so if you go to your y equals screen and you hit enter on the equal sign, it'll actually turn it off, so it won't graph this line anymore. Then I'm going to go to my plot and let's see, second y equals to stat plot. I'm going to keep my scatter plot, but I'm going to change my y's to my residual. So I want to go to second stat to get my list. I'm going to go down to number 7 for residual. And I'm going to go ahead and hit enter there, and I'm going to hit zoom 9. And now you can see that same residual plot that I had here. That's how you get a residual plot on your calculator. All right, just so you guys are aware of how to actually get these. All right, so back to our concepts here. Now this one, we have a lot of points, but you can clearly see it sort of dipping down and then back up. So this one, there's a curve, and specifically it might be quadratic or it might be exponential or something like that, so it's not linear. All right, and I want you guys to go through the rest of these and identify if there are any patterns that you see that should be taken into account, or if it looks fairly evenly scattered around this residual equals 0 line. All right, so go ahead and do this within your small groups, and we will check back. And if you are not in my classes, thank you for listening, and I hope you have a wonderful rest of the day.